Hello viewers, in today's session we are going to discuss another important problem from functional equations, and in this session we are going to solve this functional equation where we have minus pi f of x plus 1 over pi f of minus x is equal to sine 2x, and we have to solve this functional equation for f of x, right? So we have to find the function f of x, where the function f is from the set of real numbers to the set of real numbers, right? So let us start. Viewers, we have already solved a few problems related to functional equations in our earlier discussions, and we have also discussed the methods and the techniques how to solve functional equations, right? So here one technique which we are going to use is we can replace this x by minus x in this equation, right? So replacing this variable x by a negative of x, we can form another functional equation, that is minus pi, and here we have f of minus x, that is replacing this x by a negative x, and here we have 1 over pi, and when we take x is equal to a negative x, that is replacing x by negative x, this negative x becomes positive x, and here we have a sign of minus 2x, because we are replacing x by negative x, right? And sign of minus 2x, it becomes minus sine 2x, because from trigonometry we know that sine of minus theta is equal to a minus theta, right? So now we have another functional equation which is as a result of replacing x by negative x. So now let us call this equation as equation 1, and this equation by equation 2, right? Now for convenience or for simplicity, let us replace f of x by a and f of minus x by b, right? So this equation number 1, it assumes the form minus pi a, and here we have 1 over pi, and f of minus x can be replaced by b, and here we have sine of 2x, right? And equation 2 takes the form, when we replace f of x by a and f of minus x by b, we get minus pi b, here f of minus x is b, and then we have 1 over pi, and here we have a, and this is equal to negative sine 2x, right? So now we have two equations which are similar to a system of linear equations in the variable a and b. So now the second step is to eliminate this variable b, as we do while solving a system of linear equations, right? So let us equate the coefficients of b in these two equations. So what we will do, let us multiply this equation throughout by pi square, right? So we'll get here minus pi cube a, and here we'll get pi square over pi. So here we have pi b, and here we have pi square sine 2x, right? So multiplying this equation by pi square, we have obtained a new equation, right? So let us call this equation as equation number 3, and this equation as equation number 4, right? So now let us add equation 3 and 4. So adding equation 3 and 4, we can easily conclude that this term and this term get cancelled, and here we have 1 over pi a, and here we have minus pi cube a, and here we have minus sine 2x, and here we have pi square sine 2x. Right, now taking a common in these two terms, we have a and 1 over pi minus pi cube, and here we can take sine 2x common, so we have minus 1 plus pi square. Now simplifying, we have here a, and then we have 1 minus pi raised to 4, multiplying this pi with the pi cube, and here we have pi, and here we have pi square minus 1, and here we have sine 2x. Right, now let us arrange the terms here. So we have pi multiplying pi over here, and here we have pi square minus 1 divided by 1 minus pi raised to 4, and here we have sine 2x. So now using some algebra here, we can now write 1 minus pi raised to 4 as 1 raised to 4 minus pi raised to 4, and this is 1 square whole square. Then here we have pi square raised to 2. Right, so now we have a square minus b square, so we can now write 1 square minus pi square, and here we have 1 square plus pi square, so this is 1 minus pi square, and here we have 1 plus pi square. So now from this equation we can write pi, this is pi square minus 1, so we can now write pi square minus 1 sine 2x, and in the denominator we have 1 minus pi raised to 4, which can be replaced by this expression. And if we can take negative 1 common here, we have minus pi square minus 1, and this is pi square plus 1. So here we have minus pi square minus 1 and pi square plus 1. Right, so we have taken minus 1 common over here, so that these two terms get cancelled. So now we are left with minus pi, then we have sine 2x divided by pi square plus 1. So now a is equal to this expression, and we have earlier assumed that a is equal to f of x. So the function f of x is now equal to minus pi sine 2x divided by pi square plus 1. Right, so this is the required solution of this functional equation, that is we have obtained the form of the function that is f of x. Right, and here we can see that minus pi over pi square plus 1 is a constant, so we can replace minus pi over pi square plus 1 by taking this expression is equal to say k, then f of x takes the form that is k sine 2x. Right, so this is the required solution of this functional equation. So now let us see whether our solution it satisfies this functional equation. Right, so let us replace f of x by this expression, and f of minus x by replacing x by minus x in this expression. Right, so we have the left hand side, that is LHS is equal to minus pi, f of x is minus pi sine 2x divided by pi square plus 1, and then we have 1 over pi, and f of minus x is given by minus pi sine of minus 2x, and here we have pi square plus 1. Right, okay, so now let us simplify. and here minus and minus when multiplied together it becomes positive. So we have pi square over pi square plus 1. This is sine 2x, and here we have sine minus 2x. Sine minus 2x is minus sine 2x due to this result. So here this negative is multiplied with this negative, and we get positive. So we have here this pi and this pi get cancelled, so we are left with only sine 2x divided by pi square plus 1, right? So now taking sine 2x common, so we have pi square over pi square plus 1 over pi square plus 1. So this is sine 2x, and here we have pi square plus 1, and in the denominator we have pi square plus 1. So now these two terms get cancelled, so we are left with only sine 2x, which is our right hand side, right? So this is the required solution of this functional equation. As we have seen that this function, it satisfies the given functional equation. Hello viewers, in today's session we are going to discuss another important and conceptual problem from derivatives, right? And here in this session we are going to discuss this problem in which we are given a function f whose domain is 0 to infinity, and here this is an open interval, so the function f is from 0 to infinity to the set of real numbers r, right? And this function is given to be differentiable function, and further we are given that f prime of x square is given as 2 minus x cube for all values of x greater than 0, and f of 1 is given as 0, and we have to find the value of f of 4. So now this is a very easy problem, and here we are given the value of the function at this point, that is x is equal to 1, that is f of 1 is equal to 0, and we have to find the value of the function at this point, that is x is equal to 4, right? So we are given that the derivative that is f prime of x square is equal to 2 minus x cube. So we'll start with this expression, right? So our aim is to first find out the form of the function, that is f of x, right? So we'll find the function f of x, and then we can easily determine the value of f of 4. So we'll start with this expression, that is f prime of x square is equal to 2 minus x cube, right? Now see here the input is x square, right? And if we closely observe this equation or expression, then we can see that this is a functional equation in which the derivative of f is involved, right? So let us replace this x square by some other variable, say t, right? So we'll replace x square by t, or in other words we can say that x can be replaced by square root of t, and here this t is greater than 0, because here we are given x greater than 0, right? So this equation now takes the form in terms of t. So we can now write f prime of t, and here we have 2 minus x cube. Now x is equal to square root of t, so here we can write square root of t raised to 3. So now we can write 2 minus t raised to 3 over 2, right? So now we have f prime of t is equal to 2 minus t raised to 3 by 2, and again replacing this t by x, because this is a dummy variable. So we can now write f prime of x is equal to 2 minus x raised to 3 by 2, right? So now we have here d by dx of f of x, and now this is a differential equation, and we can easily find out the function f of x by integrating both sides with respect to x. So integrating both sides with respect to x, we have this expression that is d by dx of f of x, and we are integrating with respect to x, and here we have 2 minus x raised to 3 by 2, and here we have dx, and c is the constant of integration. So now here we have f of x, and here we have simply integral 2 dx, then we have integral x raised to 3 by 2 dx, and c, and this is f of x. The integral 2 dx is simply 2x, and here we can use this result, that is x raised to n dx is x raised to n plus 1 over n plus 1. So here we have x raised to 3 by 2 plus 1, here we have 3 by 2 plus 1, and c is the constant of integration. So now we have f of x is equal to 2x minus this is 3 by 2 plus 1, that is x raised to 5 over 2, and in the denominator we have 5 over 2, so we can now write 2 over 5, and here we have c as the constant of integration, right? So now to get the value of f of x, we have to find out the value of this constant of integration c by using this condition, that is f of 1 is equal to 0. So when x is 1, then f of 1 is 0. So substituting these values in this expression, we have f of 1, then we have 2 times 1 minus 2 over 5, and here we have 1 raised to 5 over 2 plus c. Now f of 1 is equal to 0, so this is 2, and we have minus 2 over 5, and 1 raised to 5 over 2 is simply 1, and here we have c. So solving this equation for c, we have 0, then we have 5 times 2 is 10, 10 minus 2 is 8, so we have 8 over 5 plus c, and from here we get c is equal to minus 8 over 5, right? So now taking this value of c equal to minus 8 over 5 to this expression, we have now f of x is equal to 2x minus 2 over 5 x raised to 5 over 2 and minus 8 over 5. So this is the required function f of x. Now we can easily find out the value of f of 4 by substituting x is equal to 4 in this expression. So we have f of 4 is equal to 2 times 4, then we have minus 2 over 5, and here we have 4 raised to 5 over 2, and then we have minus 8 over 5, right? So this is 2 times 4 is 8, and here we have 2 over 5. Now 4 raised to 5 over 2 can be written as 2 square, and here we have 5 over 2. Now 2 and 2 get cancelled, so we are left with 2 raised to 5, that is equal to 32. So now here we have multiplied, that is minus 2 over 5 times 32, then we have minus 8 over 5. Now simplifying it, so we have 8 minus 64 over 5 minus 8 over 5. So now f of 4 is equal to, here we can take the LCM, that is we have 5, and then we have here 40 minus 64 minus 8. So this is 40 minus 64 minus 64 minus 8 is minus 72, and here we have 5, so this is minus 32 over 5, right? So the value of f of 4 is equal to minus 32 over 5, right? So viewers, this is how by making use of these concepts we can easily find out the value of f of 4 using f of 1 is equal to 0.